Hi, my name is Ri Jian. Today, I would like to introduce my final project of Big Data Systems in Practice. First, we need to understand our goal for this project. For this project, we are going to build an intrusion detection system. The task that the intrusion detection system is going to do is detect the abnormal detection. In other words, classify the different type of internet connections. Before we talk about how to design the system, let's go into the data of the system. We are going to build the system. The data we are going to use is the 10% subset of the KDD CAP 1999. And then we analyze the label of data. There are 24 types of tags in the training dataset. Also, there is 14 additional types in the testing dataset, which means we cannot learn all the connection types in the training dataset. But we can categorize all the connections into 4 groups. The 4 groups are as shown below: a proofs, denial service, user to root, and remote to local. Then we look into the feature of the data. There are 41 features for each record, which comes of 3 different aspect of view. You can look the KDD CAP page, search by the Google, and to see which 3 different point of view. So 3 of the features are string labeled attributes, and the rest 38 of them are number values. The following table, we are showing the statistical result of the data, so we can see some problems from this table. First is the high duplication rate. As you can see, the last second column of this table, the duplication rate is quite high for the probe and DOS. And the second problem of this data is the normal and the DOS connections dominate the distribution of the connections. Another problem we can see for the data is high dimensional data, because the high dimension means we cannot apply this data to some specific machine learning model. After we see the data of we are going to use to build the model, let's say how should we approach the classification task? Traditionally, there are 2 ways to approach this problem. The first is rule-based model, and the second is expert system-based model. Both of the 2 models has their own problems. The rule-based model can only detect the known attacks. So for the unknown attacks, it cannot detect. So the expert system-based model is easy to trigger the false alarm. So that's why we are using the machine learning model, which we can tune the parameter to approach a balance of these 2 existing model. Then we are to see what I have done for this project. I divide this report into 5 steps. So let's go through the report step by step. So the first step is we are doing a binary classification. Basically, we pre-process the data. We only label the data with normal connection and abnormal connection. We do not classify the specific kind of abnormal detection, DOS or probe or U2AR or R2AR. That's not important. And also we change the string labeled attributes into numeric values. So let's say there's some 3 different machine learning models, how they recognize the different types of connections. As we can see, all the 3 models approach more than 90% accuracy. This is quite satisfying for the machine learning model. The following 4 part of the R code show how I finished the machine learning model using the machine learning model to finish the binary classification task. Step 2 is we change the label of the training data into 5 types. 1 type is normal, another 4 types, we categorize all the 38 or the 24 types of connections into 4 groups. As you can see, the 5 groups are normal, probe, denial service, U2R, R2AR. The second step is the same as the step 1. So let's say the naive Bayes machine learning model to approach this problem. As we can see, the DOS and normal has a satisfied accuracy for this project. However, the probe and U2R has a very, very low accuracy. While the reason may cause this problem is the DOS and normal denominate the distribution of the connections. The following code show how I train the model and do the prediction work. Step 3 is we are trying to do some feature engineering for this project to see whether feature engineering can improve the efficiency of the model or the accuracy of the model, or both of them. So let's think what kind of feature engineering we can do for this project. First, we are trying to use PCA, which we can reduce dimensional of the trained data, so we can apply the data into more general machine learning model. And the second is the feature selection. For the feature selection, we have two ways. First is a zero variance mean, to use the non-zero variance to select some useful features that will expedite our training process of the machine learning model. And the third kind of feature engineering we are going to do is the normalization. So first, let's say the feature selection using non-zero variance. We can easily implement using R code to finish this task. The code shows how I finish the project and comparing the running time of the model doing training predicting without feature selection and with feature selection. As we can see from the result of the code, the accuracy almost keep the same, and the running time almost reduced by half. So it's quite a good way to do feature engineering to improve the performance of the machine learning model. So step 4 is we are trying to combine the machine learning task with Hadoop, because the training data of this project is kind of huge. It costs a long time for a single machine to do the training and predicting task. So Hadoop has ability to handle a large data set. So we are thinking whether we can combine the two techniques to finish the project. So to do the machine learning based on Hadoop, we have many different ways. We can use Spark, Hadoop, Java with MapReduce framework, and Mahout or H2O. All 5 of them provide a very good way to approach this problem. After experiment, we are decided to choose the H2O because the configuration of this platform is very easy, and the web UI is very user-friendly, and most importantly, it supports to do the machine learning task using the big data platform Hadoop. So as you can see, there is a screenshot of the H2O web UI. It's very powerful. It has many machine learning model, and we can train it on big data platform. So next is we use the big data model to train the data we have. As you can see here, both the DOS, normal, and the probe detection has a quite good improvement based on the machine learning model we mentioned before. But the R2R and the U2R has an extremely high error rate. This might also caused by the DOS and normal dominant distribution of the connections. Also, the following confusion matrix is for the tenfold cross-validation of the training data set. The reason why we choose random forest instead of other machine learning model is based on the accuracy it has a high accuracy. We already improved on the normal and probe and the DOS connections. Also the efficiency, it can handle a large data set very easily. Combined with the Hadoop, we can handle the large dataset also very effectively. Also, it has a good ability to handle the high-dimensional data, unlike the single decision tree. The most important is it can show the estimation, what features are important in classification. We can see this picture here show that the different features, whether it is important to in the classification work, and also there is also other advantages and disadvantages of random forest. We just skip them. If you are interested, you can look into the principle of the random forest. The final step here we are going to do is what future work we are going to do for this. A good function H2 provides us is it can compare different model in the web UI called multi-model scoring, and the following confusion matrix is a 5-fold cross-validation based on the original training data with basic processing. Here, pre-processing only we only change the string value into numeric value. Here, we can also do some feature analysis for the labels, for the attributes. For example, the 7th features land. If we do a statistic, we can see only 22 of them has the value 1, and almost all others has the value 0. So this contributes very little in classification task. Similarly, there is many other attributes has the same problem. Also, there is another idea to approach this task. Another thought in my mind is we can build the file binary classifier to do classification task. When a record input, we can let them to pass the classifier one by one. Once the current classifier can classify the connection, we just stop it. Otherwise, we let it pass. The final classifier, the normal classifier, will decide whether we have confidence this connection is normal or not. If it is, we do not have the confidence to say this connection is normal, we just put it into a candidate pool to let manually classify the connection and put it into the training data set for future improvement of the machine learning model. Finally, I would like to do the summary of the project. From this project, we can learn a lot. Most important for me is the following points. First is we need to understand the pros and cons of different machine learning model because it's quite helpful for you to choose different kind of model. Second is data pre-processing is very necessary. It includes the feature engineering. So the third point is think out the box. In this project, we combine the Hadoop and the machine learning job to do the large data set based machine learning task very efficiently. And the last point is done is better than perfect. When you have an idea, just finish it, implement it, and to see whether it works. So that's all of my final project, beta systems